All right, so I started the recording. Thank you everybody for joining us for another session of the Data and AI Architecture Virtual Group. Today with us, Sebastiano Galazzo. He was mentioning more than 20 years of experience in the AI ML space, also Microsoft AI Platform MVP. Thank you, Sebastiano, for giving us some of your time today to volunteer for this, for the virtual group and to share your knowledge with us. Thank you as well for everybody that joined us today. We know you have a million other things competing for your attention, but you decided to take 1 hour to learn with us, and we really appreciate it. So without further ado, I'm gonna give the floor to Sebastiano. I'll be here moderating. I'm going to mute and turn off my camera as well. I set the spotlight to Sebastiano, and yeah, thank you again, and let's go.
So thank you. First of all, thanks for the invitation, and it's a pleasure to be here, of course. And let's go straight to this topic. I will share my screen so I can share some slide. Okay. And
yeah, we can see it good.
Perfectly. Well, I want to start very soon to explain what it is the main goal of this session. The goal of this session, of course, it's to tell a story, my mistakes along at the trip creating large language models, and to share some information that I earned paying a lot in terms of time, but also in terms of money. There are some slides that costed to me 20,000 euros or dollars, more or less the same thing. Why? Because to find the perfect parameter that I will show you in one slide costed to me six months of attempt in training. And I believe that that's the knowledge that it's useful to share with other people, because everybody are old enough to read a very good tutorial in the web, on Medium, or downloading code from Hugging Face or GitHub. We are all developers, so you don't need to need that show some portion of code at that level, but to share very important resources that I wasted a lot of time to find the perfect tool that worked, of course, to me, or the perfect parameter or the perfect technique. And when I mean perfect, is perfect to me, of course. And that's another very important point. What I will share, it works very well for me. I cannot say that is perfect also for you, but the goal is to provide all the tools, the resources, in order to be aware of what you have to expect, first of all, but after, what kind of tools you need in order to be much more autonomous. Well, said that, what we want to do again is to create our own large language models, but we don't want to reinvent the wheel unless it's not necessary. So when it's possible, we will use tools or ready-made that we can come from Hugging Face. Again, we can download open source models and then do fine-tuning, code from GitHub or tools from Microsoft. Here, I say I mention Microsoft just because of my connection, but of course, doesn't matter. You can use also AWS because everybody has the GPU or services like that. In my opinion, not just because my connection, I don't work for Microsoft. In my opinion, they provided the best resources, but it doesn't mean that you cannot use also AWS. Well, the question is why I should create my own large language models. We have OpenAI, and everybody believes that is the state of the art. But is it true? Not always. I'm not saying that OpenAI is not good. but is not God. That's an important key point, because there are a lot of scenarios where OpenAI could be amazing for your needs, but there are another portion of probability that for your business, for your customers, OpenAI is not enough, because generative AI fails. You must accept that this kind of technology is impressive, a lot of opportunities can give to you, but is failing. It fails, can fail. And there are same scenarios where this is acceptable, but other, maybe finance, health, I don't know, doesn't matter. If your business requires a very low failure rate, maybe that you need to create your own large language model. And then here we are. Anyway, as he said, it doesn't mean that just because we will use open source models is for free. Everything has a cost. So it's up to you to understand if it's worth to use OpenAI or Claude from Anthropic as a service, or rely on your fine-tuning model. So talking about large language models, then tools like ChatGPT, to simplify the kind of model that we are talking about. If we want to fine-tune something, my suggestion is to start from this version of Mistral. I can share my slide, so there are a lot of active links, so you can go straight to download the tool of the model. Today is available version 3 of this model, but in my opinion, I tried, and I guess that version 2 is a little bit better, despite it is a version before. What is the, again, always in my opinion, the point of strength of this model? That is very, very easy to train compared to Llama 3 or other models. I'm not saying that Llama 3 is not good, it's a great product, but based on my experience, same dataset, same parameters, let's say, I get better result with Mistral, or at least I have to struggle less with Mistral. So my suggestion is to use this version of large language models about Mistral. But training a large language models is very expensive. Just to understand what it means expensive, a very small model from Microsoft, fee-free, okay, PHI free. That is a very, very good model, but it's small. And it was created for research purpose, let's say. It's been trained for 2 weeks using 96 GPU. 2 weeks, 96 GPU. I pay one GPU $2,000 per month. So I guess that is not needed to make your calculation, but could be very expensive, and is just a toy compared to other models. But why that? Because you have to imagine a model is, of course, it is a very huge simplification, okay? In order to be much more understandable for people that are not technical. So if there is someone that knows a bit better how it works, so don't blame me. I have to explain things in a very simple way in order to allow people to understand the principle, okay? Say that you have to imagine a large language model like a very big matrix. We thought when we read 7B, it means 7 billion parameters, and it's just a toy. Okay. Well, it's impossible for common people like us to have the resources, to have the money to train this kind of models. But there are some math that can help us. And in this case, the math is the name of Lora. Lora comes from low adapter rank and how it works. As you can see on the right, we have two vectors, the vector A and the vector B, that multiplied together in this way, we can create a matrix. So what is the idea? It's very simple. Instead of training all 7 billion parameters, I train just one row, one column, sorry, and just one row or a vector, and then multiply it and add on top of the original model those weights. And it works in an amazing way. So you can understand that the number of parameters that you train is dramatically low. We talk about just the 1% of the whole parameters. So to have an idea, using a machine that is made by 4 A100 GPU, that could be expensive, but affordable, to train a model like Llama 3, like Mistral, I can spend 3 days. 3 days are nothing compared on training for 1 month, 2 months using 100 GPUs. So you can save a lot of money and the results are amazing. But you have to understand some key points. We have two parameters that, in my opinion, are very, very important to understand: the R value and the alpha value. And those are the slide that I said costed to me 20,000 euros. Because when we get some code from Medium, from Hugging Face, we have a ready-made code. More or less, we do cut and paste, but we don't know what some parameter means or how, which kind of effect they have on the results. But there are values that are so simple in that slide, but they are game changer, or the good or the bad, depends if you use the wrong or the right parameter. Well, talking about the R value is the rank of the matrix. To explain very, very easy, here you can see that the R is how wide is this vector. Honestly, we know that a vector has dimension 1, so it means R1. But if I use, for example, an R value made by R16, it means that there is no more a real vector, but is a matrix. It's wider. And then multiplied together, I get again a matrix to overlay over the main model, but I can train much more parameters. Anyway, far, very, very far from 7 billion parameters, but you can train much more values. So, do not believe that an higher value, it means always a better result. It's not true. Based on my test, if you use a parameter that is too small, it's not good. Too high, you get overfitting. So you have to do a lot of tests. Each test, it means 3 days of training. So here is the best configuration that worked to me for the R value. 32, but you can use also 16. No more, in my opinion. That is a value that costed to me a lot of effort and pain to understand the best value to use. But first of all, we have to understand how it works. So this is a value that is connected, is related to the R value, and it's like a ratio. So if you have an alpha value of 64 and an R value of 32, it means that you have an alpha Lora of factor 2. Instead, it's very simple. If you have the same value, you have an alpha value of 1. But what it means? Simple. It's like a damping factor that is used when you add the metrics that you created or using LoRa over the original model. It's a way to put much more emphasis of your training over the original model. Again, do not exaggerate, because if the value is too high, the risk is that you lose a lot of the capability of your model to generalize. But it will be much more focused on what you trained. I'm not saying that is bad, neither that is good. You have to know very, very well this behavior, and you have to adapt based on your needs. 20,000 euros, 6 months of paying. Well, now we know that we can create a very small model, yeah, that we can overlay over the original model in order to customize the foundation model. But what if I could train several small models, several LoRa, and dynamically change it based on the query of my users? So the idea could be to train a LoRa that is expert in legal, another LoRa that is expert in automotive, in poetry, philosophy, I don't know, I don't care. But the idea is to swap these models in real time. It can be done. It's not my favorite techniques, but you don't have to do it from scratch. You can use a tool like this one that you can download, of course, from GitHub. You are old enough for sure to understand how it works. Installation in Python is not my job, as the session will would be 6 days. So here there is the resource, in my opinion. Well, now we talk about another technique that I like much more, that is named, that is based on merging other models. This technique is also known as Franken models, from Frankenstein. I like this German word, Franken models. Anyway, the best tool to do that, in my opinion, no doubt, MergeKit. But since 2 months, I guess, I started using also the second one, that much more for models are specialized for image generation, like Stable Diffusion. Can be used also to merge models like Llama 3. Don't ask why there is the keyword Super Mario. I don't know. Anyway, it works very, very well. It's amazing, and I suggest both as resources. So here, as you can see, with one line of code, you can merge different models. What are the benefits? For example, in this case, I want to create a model that is able to generate images. So we are talking about the stable diffusion models. Okay. If you use a resource like CVTI, that is a repository of amazing already trained models that are available, you can download it and merge the base model with the new one, or 2 or 3 already trained models. What is the advantage? That just with one line of command line instruction and no training, in 2 minutes, you have an amazing model, speechless sometimes. The cons is that it's not trained by you. So you get what other people did. So doesn't mean that Lora is better than merging other models or vice versa. There are different techniques. You can use both. You can start so to reduce the amount of training with Lora. For example, what you can do is to take 2 or 3 already trained models from others, and then maybe using Lora over it to improve. You can combine all different techniques, but do not underestimate when creating your own models to use merging of models. So here we have to go fast because, of course, I cannot explain in detail all the techniques involved in merging these models. But I really like to give you the resources if you want to study much more and to go in detail. So the most simple case is when we have 2 identical models and the same initialization. So everything is the same. Llama 3 with Llama 3. Stable diffusion XL, stable diffusion XL. Same number of parameters. You have to do nothing. This is the best option. 2 minutes of job, you get a speechless model and a speechless result, with the cons that I already said. But when merging those models, you can use different techniques. Each technique has pro and cons. I don't want to tell that one technique is better than other. I tried almost all of them, and I don't have the idea that one is better than other. Just depends on your needs. So up to you if you want to deep this topic to study how they works, or trust me, use default parameters. Easy life, 2 minutes of your life. Amazing. Anyway, you can have the same architecture but different initialization. For example, a model, we can have 2 different Llama 3, two Llama 3 models, but one has been modified a little bit. Then you cannot merge as is with just one command. You have to use other techniques, and here are the 2 kind of techniques that you can use. Again, I go fast here. Once I share my slide, you can deep the topic. The goal of the session is to provide the tips and the resources. Okay. Well, the worst case, and I don't want even to consider, because if we are in this situation, maybe is not the best option, in my opinion, when we have different models and we want to merge. Is possible, but doesn't work. To do that, if you want to do that, maybe there is something wrong, in my opinion. Well, another technique. In this case, so far we say that we can fine-tune and that we can merge together already trained models. But what we can do is to use a technique that is named the mixture of expert. How it works? So basically, it works first that you need mandatory the same model, the same architecture for each expert. So I fine-tuned, let's say, Llama 3 or Mistral, one model for one task, another model for another. Again, photography, for example, another model is fine-tuned to be an expert on legal, another model is fine-tuned to be an expert on code production, another model is an expert on translation, for example. Well, here in there is a gate for each layer that, based on the query of the user, addresses the use of that layer based on the context. When I will show you the configuration file, will be easier to understand. Don't worry. I can understand that watching at this slide could be difficult, but you have to imagine that there are a lot of very, very little routers that address your request along a branch. What is the benefit? First of all, performances, because for sure you have multiple expert, that it means multiple models, but you use just one model or at least two models at time. So if I have a Llama 3 that has 7 billion parameters and I use a mixture of expert of 4 experts, it means 7 by 4. Okay, but when we run the inference, doesn't mean that I use all 4 models, but just the branches that are useful, that are semantically close to my request. That means that I could have the power of 60 billion parameters, okay, whatever you want, running just what you need. And that is game changer. But also, what it is the best pro compared, for example, to merging models? That in this case, I can leverage the knowledge of more than one model. Because if I have, to simplify, just one model, or it is specialized on translation, or, for example, in summarization. Of course, it is able to do everything very, very well. But mixing expert, I can have the knowledge of a model that is for his total fine-tuned for translation, and the knowledge of a model that for his world has been trained for a specific task. So I can merge all this knowledge. The only cons is that I can save time in terms of execution, but the amount of memory that I need, of course, is the sum all of these models. But we talked too much. Looks like it's so complicated creating a mixture of experts, but using MergeKit, as you can see, is just one line of code and a configuration file. Very, very, very easy to create. As you can see, you set the base model and then the list of experts. You put the path of the models of the expert, in this case, V35 merged, V34 again merged, because I can mix all the techniques. And then what we have to provide is very, very simple. As example, by example, a list of prompt that helps the router, the main router, to understand where to address your request. So it's a way to say, look, when we have a request that talks about photography, adjust to this model. Not for translation. For translation is better to use the model named V34. So just one configuration file, very, very easy to understand and to create, and one line of code. I explained a very little bit of theory. I understand that could be complicated, but believe me, you don't need to understand all the details of the theory behind. Real life, just understand what or know what are the best tools, configuration file, create what you want. Okay, now before introducing how to create a multimodal models, we first have to understand how it works, how they work, sorry. But before, we have to understand the process of embedding the content. So, as you know, I talked about the big metrics. Metrics, it means numbers, but you know that here, everything is math. So, large language models, like machine learning, like everything in this case, understand just numbers. They do not understand letters or words. So, how we can do that those models are able to understand text? Simply converting into numbers. That is something that these models are able to understand. So the idea is to have a big dictionary, not made of words, but made of tokens. What are tokens? Tokens are a portion of words. More in the average, they are made by 3-4 characters, charts. And using tokens and combining them, you can create all the words in the world of all languages. This is the reason why we do not use a dictionary that is made by words. Of course, also which kind of dictionary you use as an impact, but this is another story. What you have to understand is that each token is converted into a vector. You create a vector of so the list of vector that you create based on the text that you provided as input creates a matrix, and that's the input. Maybe in this slide it's easier to understand. So the real input of large language models are vectors. Okay. Here the idea, how I can make models able to understand images, for example, or audio or video or other kind of text that other kind of input, sorry, that are not text. So the idea is to use tools like, for example, for images, we can use the convolution. For audio, we can extract the frequencies, the most important frequencies, and convert, extracting and convert using again the convolution, extracting vectors as input. So if we would be able to convert images, text, audio, video with the same format used for the text, they can be used as input for large language models, and then I can get not just text, but also images, audio, and so on. To do that from scratch is a pain. Don't do it at home. It's not for everybody, but not because people are stupid, of course, because it's really, really complex, a waste of time, and there is no need to do it at home alone. What I suggest is to use tools ready-made, like this one, multi-token, that does the dirty job for you. When is possible, do not reinvent the wheel. So again, using this tool, you have no idea of how much time and money you can save, because you should train some portion of the model. I don't want to go in detail. Maybe if there are any question, or you can contact by mail if you want much more detail. Of course, we have to run because we are consuming a lot of time, and I cannot provide in details how it works exactly, but just to explain in a high level how it works, and then provide the tool. But if you want, here I am, and we can discuss about the details. So here is how it works, using just very few lines of code. Here is an example of a request. As you can see, it has the same structure of syntax that we use to call OpenAI request. So if you have a project that already talk with OpenAI, don't worry, you don't have to write everything again just to switch the endpoint, because the syntax is the same, except that we have one more parameter, images in this case, pass a link to the image or audio or document, in red the other tags, depends on your configuration, and here the output. Easy peasy. Okay, I don't want to talk too much about voice cloning because it's a very complicated topic. Just I want to provide this resource. I can tell you it works really well. Maybe the best that I had the pleasure to use. Is not that complex to train. Results are amazing. When I talk about voice cloning, there are a lot of people that how to say, don't like too much this topic. In my opinion, is wrong, but I don't want to talk about that. But simply, okay, got it. That's the resource. Again, if you want to deep the argument, don't hesitate to write to me. It will be a pleasure. But here, it's more than enough to provide straight the project that I wasted months to find the perfect tool, the perfect project, and here shared. You can use also for text to speech, you can use also product from Microsoft, of course, but you cannot customize because they are supposed to have, they have possibility to customize speech to text with your voice, but it's not for everybody. This technology is very, very locked, and Amazon, Microsoft, other do not provide the possibility to customize to everybody to customize to clone your voice. Here, that's the project, no more. Okay, we have created our large language model. Is great, is perfect, but cost saving comes also not in terms of creating the model, do not using OpenAI, but also when talking about performances, because if a model consume 4 GPU to run an inference against 1 GPU, and 1 GPU cost $2,000 per month, you save a lot of money. So we can do a lot of things. The first approach that we can use is pruning. Now I will explain how it works very, very quickly, and don't worry, we are going to finish because I know that looks like that we are talking for 2 hours, but we are going to finish. And before I explain how it works, pruning, here are the best tools that, in my opinion, works. And for people that don't know how they works, pruning, as the name suggests, we go to cut some branches from the model. But why? Some researchers demonstrated that when you run the inference, not always, not all the weights of my model are activated. There are a lot of neurons that are always to zero or most close to zero. It means that of 7 billion parameters, maybe 1 billion, 2 billion, it also depends on the threshold that you want to use, are useless. Then you can cut. Unfortunately, it's not so easy to understand what it means useless. There is still an active research on creating the best tool that is able to detect very, very well the neurons to cut, to delete. But the ones that I provided to you, in my opinion, works very, very well. The takeaway is that you can use a threshold, and despite you can cut not just the ones that are close to zero, but if you want to reduce the model a lot, because for example you want to it run on an edge device like Raspberry or on mobile phones, you accept a reduction of performances, of course, but you can hide the threshold and you remove, in order of importance, much more neuron or compared to the original one. Well, again, how many neurons to cut, it's up to you. The default is the one close to zero, and that's already a very good reduction. The other technique is very, very simple because you have to do nothing. It's just a configuration parameter. It's named the quantization. How it works, you know that each weight of my model is a floating point. value. A floating point is made by 4 bytes. Well, if we use different representation, like instead of 4 byte that it means 32 bits, 16 bits, so FP16, we reduce by half the amount of memory and speed that is needed to run the inference, but also the training of the model. You can push yourself to use also integers 8-bit. Integers are faster than floating points. You can use even 8-bit. There are some situations, some people that produce the result using integer 4-bit, but in my opinion is too much. Yes, the model is fast, can run even in a Raspberry, but I guess that you can understand that when you cut too much or reduce the precision too much, you of course lose in terms of accuracy of your model. Again, how much, it's up to you. What I have to do is to explain how it works, and then you decide what is better for you. Another important aspect is the KV cache of large language models based on transformers. It's a very complex argument and is not that easy to simplify in a few words. So first, I suggest to read that article. Is a very, very good starting point. So how it works. First, we have to understand what it is the KV cache. As you know, large language models, how they works. They predict the best next word based on the past. Okay. To do that, we need a storage, really to simplify. Okay. Is a really big simplification. You need a storage that that stores, of course, all my text or the text that I produced so far. So I can predict the next word with the highest accuracy better. So you have to think to KV cache, so like a container, and the dimension of this container has a direct effect on the performances. Here there are some numbers that you can read at home with much more calm. In this case, of course, the more you reserve for KV cache, the better performance you get. It means also much more memory to use, of course. So it depends on your machine. It does not speed up the single inference, but the higher is the amount of this space, the more requests in parallel you can process. More or less, you have to think in this way. Okay, but how can I affect KV cache? Is not that easy, so you don't have to do it at home. What I can suggest, you can set some parameters using the diffusers library, so by code, but you must be a little bit more than an expert to understand how to configure the KV cache, unless you don't do it. Simply use servers like Llama CPP, TensorRT, VLLM are amazing tools that can speed up the performance of your model and do it for you. And you have to do nothing. Of course, if you want, you can configure your parameters, but if you are lazy, and that is my suggestion, be lazy in this case, let this tool do your job. It works very well. Okay, when talking about reg, and then we finished, don't worry, it's really the last topic. I guess that everybody knows what RAG it is. So basically, you know that large language models as knowledge, as an inner knowledge, but are trained up to last December. It's just an example, okay? But they do not have, and they cannot have real-time knowledge, for example, or what happened yesterday in Europe is not an information that you can have, or your personal ticket from Zoo. Of course, it's inside your database. Large language models cannot be aware of this kind of information. So what you do is to create some tools that, based on the query, grab informations from your database, again, to simplify a lot, and use a portion of this information like context for the large language model to answer to the query. So if I ask, please give me the results of the match of yesterday between, I don't know, two football companies, okay? And what I do, I use Bing API, Google API, grab the page from the internet and use the content of that page as a context, and then having that information, then the model is able to reply. But how we can search informations on our database not based on a keyword or query? So we use techniques that is named embeddings. The embeddings is a kind of semantic similarity, are used for semantic similarity. They works like the embeddings that I explained before. So I convert my query into a vector. I convert my paragraph, my portion of information into a vector. I do cosine similarity, and that gives me the semantic similarity score. And so I can grab from the database all the paragraph that talks about that argument. You can use different and several embeddings engines. The first one is the one comes from OpenAI. In my opinion, that doesn't work. Why? Because, but it's not just said by me. A lot of people confirm what I'm going to say. It happened that if I ask, please find me all paragraphs that talks about the pizza, I get the score between pizza and pizza cheese, for example, with a score of 87%. The problem is that happened that pizza compared to motorbike could have a score of 1882. So the first one is the correct paragraph, but you cannot set a threshold to discard paragraph that doesn't match that semantically with your query, that are not so close with your request. Then what I did, and this is a personal project, of course, is not intended to think that is the best solution in the world, but it worked to me, and I want to share with you. I used this model, the last one, Mini LM L12 V2, that specific model. It's very, very old, very, very small, and very, very fast. What kind of issue we want to address? You have to understand something important. Let's say that we have a document that talks about the comparison between Audi, the car Audi A6 and the BMW M5. So if I say document, the whole document, we are talking about the comparison between Audi and BMW. So if I have to retrieve this document, this is the topic. But inside that document, if I split into paragraph, how big is the paragraph? Is game changer. And unfortunately, there is not the perfect size because it depends on the document. Because it could happen that a portion of that document, a portion, so the paragraph maybe is talking just about the performances of BMW M5. So you understand that if I have to retrieve something, this portion of text is not talking about the comparison between Audi and BMW. It's talking about just the performances of BMW M5. It's something different. If I still reduce, maybe that this small portion is talking about the engine of the BMW, and the second portion is talking about the comfort, because the engine is so powerful, but is affect the comfort because of vibration. I don't know, I just inventing, okay? But if you split too much, that portion of text is talking about comfort. But the whole document is talking about the comparison between an Audi A6 and a BMW MW. So you can understand that it is not so that easy to manage document retrieval, paragraph retrieval from a database to be used as input for my large language model. What I did this technique, known that the model that I suggested to you has an input of 128 tokens, so very small portion of text. I split all the text, all the document in a portion of text of that size. What I do then is to concat some sequences of this small text, and then what I do is the match with the query. But you know maybe that compare vectors, it means that they must have the same dimension. And so simply what I do, I duplicate the vector of my query. And then I use two kinds of techniques, or a technique that is named sliding window. So I, instead of duplicate by 4 the vector of my query, I use the sliding window, and then I compare the query with that small portion and take the score, the query with the second small portion, and I get the highest. Against this technique that what it does, multiply everything, so the whole vector, the concatenation, sorry, I'm a little bit tired, but we finished the concatenation of this token with the query multiplied by 4. It's not the same thing because changes. The one is much more, is closer to a behavior that is much more related to keyword, okay? Because I compare a small portion of text with a small portion of my query. The second one is much more document aware on his wall content. So it works to me. Of course, I understand that it could be a little bit difficult to apply, but if you want some performances, not always you can grab ready-made code from GitHub or already trained models from Hugging Face. Sometimes you have to get something from scratch, like in this case. Well, I guess that is enough, because maybe a lot of people could be tired now, and that's all from my side. I understand that some portion of topics cannot be covered, because just one topic maybe need 1 day of speaking. Again, the goal was to provide my experiences, my tips, in order to give you tools to speed up the process if you want to do that.
Yeah,
So
appreciate
that's
that,
all.
Sebastiano, for sure. And I mean, you cover a lot of different concepts, so it's a good, like, all around, kind of like 360 view on all these other ways to do this. I wanted to ask you one thing that a lot of people are asking me as well lately. I dabble quite a bit into this space too, and I'm starting to, do some actual consulting for it and work. And there's been, ever since, like, I want to say maybe like a year and a half ago, we have all these libraries that try to sell it themselves as like abstractions over the LLMs, right? You're probably familiar with LangChain, for example. Um, there's this thing called Llama Index 2. Microsoft has this thing called Semantic Kernel. Have you played around with any of these? Do you find them useful? Do you think it's better to just code against the APIs directly? Are they like, bloat abstraction, not really useful? Like, I just want to get your opinion on that kind of stuff.
But my opinion is that they are very, very great tools. I tested most all of them, not all, of course. And I cannot say that they are not good. But as I said, depends on your customers. Sometimes you need an highest level of accuracy. I cannot accept from OpenAI, because OpenAI is supposed to be God, and I pay a lot of OpenAI or tools or other tools that I pay still a lot, that they compare pizza and motorbike with an accuracy of 86%. What it means that? It means that as input of my model, I will use the wrong content.
Yeah,
Well,
yeah.
if we are playing or we are in situations where it's not a problem, okay, good. But what if, for example, if I have to grab different suggestions, different financial suggestions or health suggestions, and I grab the wrong content with a very high accuracy, the generative AI by design can fail by design. If I had the wrong content, guys, is the end. So sometimes tools like that can work very, very well in a lot of scenario, but when the game is serious, and of course you asked my opinion, and that's my opinion. That doesn't mean that is the truth. It's just my opinion. I create my own solutions because I want the control.
Okay.
I don't know if I was able to answer to your question as you expected.
No, no, it's okay. I appreciate the insight and the opinion as well. For everybody that is asking, the recordings are all uploaded on the YouTube channel. You can get the YouTube channel link in the meetup page of the group. Thanks, Sebastiano, for the time once again. I'll
Thanks
be
to
sharing
you
the
for the
recording
invitation.
as well. Appreciate taking the time to share with everybody, and thank you everybody as well for joining us today. Until next time, have a good day, everybody. Bye bye.
Bye bye.